Hello, this is Martin Willis, your host, and welcome to the show. I have Marc D'Antonio on tonight. We're going to be talking about 3i Atlas and all the mysterious myths and truths, and what Marc has, as an astronomer, has looked into what's actually going on, as much data as we can collect at this time. A couple of things, unfortunately, it didn't work out last Tuesday. Something came up. The second time I've had to cancel in all the years that I remember that I've been doing the show, in 14 years. And then ironically today, Katie Page, who was scheduled for tonight, had to reschedule because of a situation as well. So I've been scrambling all day. And then I thought, what a great topic it would be if we could talk about the 3i Atlas, because there's so much going around about that, so much speculation and all that. So I contacted my good friend, Marc D'Antonio, and he said, Showa. He lived in Maine as well. That's kind of the Maine accent. He and I kind of do that when we're together by accident sometimes. But anyway, I want to talk about, I had such a blast at the Exeter UFO Festival this weekend. I was a speaker there and really enjoyed, meeting a bunch of people. There are probably some people that are here, watching tonight. Had a lot of cards and a couple of T-shirts go out the door. So I do believe there may be some new people that are listening, and hello to you new people. And here's a couple of things. Our guest last week actually came down for a visit down on the Cape, where I am right now. And we had a good time yesterday. Jean and Natalia Sticco, and very sweet lady, opera singer, amazing opera singer. And Jean has a very interesting intelligence background. It was a lot of fun hanging out with them yesterday. A couple of things. Here's Charlie Fultz. I sat beside him on a panel this weekend, and this is I'm doing my presentation here. And then this is the round table, and I got to interview this very interesting young woman about her UFO sighting, and that's going to be released coming up on this Sunday. It's an unedited version. Unfortunately, in the Exeter Town Hall, they have absolutely no place you can record anything in. You could either go into a restroom or be in that vendor room, which I was in, and just have to put up with a little bit of noise. But anyway, it was a lot of fun. And so our blog this week from Charles Lear is a 1980 Brazilian UFO abduction case. Check that out over at Podcast UFO where there's hundreds of blogs. There's to read for you. And of course, our podcast archives go back to just about 700, or I believe over 700 in total. And you can get to that through our page as well. We do have merchandise over there. You can support the show, and there's a way to do that on Patreon. The link's right there. And so let's see. I think we're just about ready to bring in. And when I say my good friend, Marc, we have been pretty close friends for a number of years, and we're going to be hanging. We seem to hang out at least 2 or 3 times a year somewhere, and was out in contact in the desert last time, and we're both going up to Shag Harbor, right, Marc?
Yeah, that's true, Martin. We're going to be at Shag Harbor.
That's right. And there is Laurie Wickens. I love him. He's a wonderful man. He's the number one witness to Shag Harbor. He's still around, and by golly, he talks just like that. And I love the guy. He's a lot of fun. Real nice guy. Real nice guy. And you're going to have a lot of fun up there, Marc. We're going to be doing a tour on a bus, in the location where the events happened.
Nice.
And I got to tell you, the people up there are the nicest. So that's coming up for anyone interested in going to. It's right near Yarmouth, Nova Scotia, not too far away from there. And it is October 2nd through the, is it 3rd through the 5th, I believe, coming up on that weekend.
Approximately correct, I think.
I think I'm approximately correct.
Yeah, no, I can't, and I owe this guy all the kudos for getting me in there, because you're the one that told him about me, and so I very much appreciate that. Yeah. So it's like, now I gotta buy him freaking dinner or something now. I don't know.
It's included anyway, but you can pretend you're buying it. Yeah. Anyway, so you do this great SkyTour live stream, and that's free for anyone to watch, and you comment on what you're looking up in the sky. We can talk about that later. But so Donna, my better half and producer, said, "Oh, check out Mark's posts on Facebook page about this three-eye atlas."
Yeah, it's pretty extensive, wasn't it? It was a pretty long. You know what it was, Martin? You're hearing all this garbage out there, and someone has to wade through the crap and just give you the facts.
Yeah.
Okay. And I just got sick of people saying, scientists say, what scientists where? Okay, that this is an alien vessel coming in with hostile intentions. Okay, they say, that's always the famous words. They say, who's they?
They.
And who's saying it?
I've always wondered who they are because they have all the information.
They are so knowledgeable, aren't they? Yeah.
Yes.
They say, yeah. And I've worked with Avi Loeb and on TV shows and stuff, and he's a good guy and a friend, I think, to me. And so, he has not said that it's an alien spacecraft. He's not said that. He's never said that. What he is very careful to say, and what should be said, is this is another interstellar object, kind of like Borisov, which came in before. Geez, I guess some of you don't know about that one. That was 2I Borisov. And before that was 1I Oumuamua. Okay. Well, first of all, they get the shapes wrong all the time. They got the shape wrong on Oumuamua, and people still think it was a long, thin spindle. It wasn't. It was a pancake. It was like this. Okay. And so with the 3I Atlas, already they're saying it's a long, thin spindle. They're making it into Oumuamua again, at least the way it wasn't originally. And they're saying that it has lights on it. No, it does not. Okay. It's reflecting light of the sun. Okay. It's inside the orbit of Jupiter right now. Okay. Maybe closer to Mars. All right. But it's passing Jupiter. It's going to pass Mars. And on the way out, it's going to pass Venus, which will have gone around by that time. And that's interesting. See, that's the part that would make an astrophysicist say, that's how we might program the course of a probe, right? So is it possible that maybe this probe is intelligent of some kind, and from an intelligence of some kind? And the answer, you can't say definitively no. Everybody says, no such thing as UFOs. Really? Well, tell all the several million people on the planet that have definitively seen something other than a satellite, okay, in the sky. All right. So obviously these things are worthy of study. And I think it's outrageous for people to just dismiss things out of hand. I've had my share of that in academia, right? I've been fighting the arrogance in academia for decades. Okay. Now, I haven't faced it in my particular schooling. I've faced it in other people's schooling and in the resultant opinions they have as a result of it. But, so yes, that article was meant to just say, okay, once and for all, this is what we know. It is not a spacecraft. No, we can't tell that right at this point. Maybe it is, but we can't tell. Right. And they don't want to hear that. They want it to be a clickbait tool.
It is doing some weird stuff. You have to admit that. Like, it's throwing off nickel, but there's no iron, which is very strange because nickel and iron should be together. And it's gassing in reverse, right?
There's a carbon dioxide coma around it that is far more extensive than what we're used to seeing with comets. With a comet, you might get 3 to 4% of carbon dioxide emission. And in this one, we're getting almost the bulk of it is of this carbon dioxide. Now, to be fair, we've never had a comet come through that came from the galactic disk. I mean, our galactic disk has a bulge in the middle, and then it tapers out to a disk, and you have spiral arms in here. Okay. Well, if the comet was created inside this disk and then migrated to us, just about, just under 2/3 of the way out, from the central bulge, well, then maybe it makes sense for carbon dioxide to be more prevalent. Maybe it makes sense for it to be extremely old. And right now, the age estimates are somewhere around 7 billion years old. Now, that's just that's more than half the age of the universe at
Hmm.
13.8. So it means that this thing's been tooling around potentially for 7 billion years. A lot happens in 7 billion years. You can have cosmic rays striking the surface of this object over and over and over all this time. Maybe that's part of the reason why there's so much CO2. Because on comets you have carbon-carbon molecules, you have CN, which is cyanogen, carbon and nitrogen atoms, and yes, cyanogen meaning cyanide, okay, which explains the comet pills being sold when Halley's Comet came around the first time, okay, because we thought we might collide with Halley's tail and fully atmosphere full of cyanide and die, but these comet pills will keep you safe. Yeah. So so comets have these different compounds, and it's possible that the long-term bombardment by cosmic rays may have changed the composition on the surface of the comet. And it's possible that as it's getting closer to, and I keep calling it a comet, I'm just saying that because at this point, that's what it looks like. Okay. It doesn't look like a typical comet, though, and I grant you, and I think that's the most interesting part. So as it gets closer, the sun is going to heat the surface. And remember, this has been out in deep space where the temperature has been close to absolute zero. And now it's reaching a point where maybe it's slightly above absolute zero, maybe 10 degrees or 10 Kelvin above absolute zero or more, meaning that that's a huge amount of increase in temperature relative to what it's been used to. So now that surface might be outgassing and starting to push stuff off. Okay. And the material coming out forward of the comet is interesting because it indicates that there's a powerful force that's driving it forward. Because the comet's coming in at 137,000 miles per hour. But there's nothing blowing that stuff back other than the feeble solar wind, okay, at that distance. And so the force pushing forward is enough to force these particles forward of the comet maybe and make this aura of carbon dioxide, and we have this strange nickel composition that's really strange. Maybe the iron is in the surface material somewhere, and for some reason it's not been released at this point. I don't know. Again, it is a enigma wrapped in a mystery, surrounded by a conundrum. So I'm fully aware that this object is very strange. It's not like any comet we've actually seen, but then again, we haven't ever seen a solar system comet that was an interstellar comet that came in from the galactic disk. Because remember, the galactic disk is where all the action happens, right? That's where stars are made and die. So a lot going on there.
And it's is it carbon dioxide also that it's gassing, which is kind of unusual, right? Do I have
CO2.
that right?
Yeah, you do.
Yeah.
And as I mentioned, in a regular comet, you might see 3 or 4% of carbon dioxide, but in this comet, it's the vast majority is carbon dioxide. I don't know the exact number, but it's way, way more into the vast majority column. And that makes it odd right off the bat. Yeah.
So if you take something like, let's just say, and this is a layman talking, just keep in mind, if you take, like, say, nickel, and you put nickel in absolute zero, what type of, does it have certain effects to it? I know that I remember being a kid and watching a science program on TV where they took a rubber ball and they put it in absolute zero and it just shattered in like glass. You know what I mean? So does nickel have anything happen to it, or does it just remain stable?
It just becomes cold nickel.
Okay.
Okay.
All right.
Yeah. Actually, that's the thing about deep cold. Deep cold tends to preserve objects and prevent them from making a lot of changes. There's many changes that are accomplished via high temperature. And when you have something in deep freeze, it's sort of preserved and stays there. The molecules are moving so little that they can't
or at all. Are they still moving?
Oh yeah, they're still moving, but it's very, 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 very little. So instead of doing this, they're doing this. Okay, you see, like a little bit, and that little bit is enough to just, keep them vibrating at the lowest ebb of molecular energy, but they still can't do things like bounce into each other, change, become something different. It would need to.
You can't split an atom at that.
No,
Not very easily, I would imagine.
That's why.
Yeah.
That's why fission projects and fission reactors are also so hot. They need cooling. Yeah, that's right.
Okay. And so here's a question from Anonymous Rex. Do you think that NASA has been transparent with the information?
NASA actually has been remarkably transparent because they also don't know anything about it. There's really not much more they can do other than look at the spectrum, and for people that don't understand what that means, when people say, what's the composition? How do we know? Well, the light coming from a comet or light coming from a star or anything, even reflected light off the moon, will present to us a spectrum. A spectrum is red, orange, yellow, green, blue, indigo, and violet, all the colors we see with our visible spectrum. Far off the red is the infrared, and far off the violet is the ultraviolet, and so forth. X-rays way out there, cosmic rays way out there. Okay, so in terms of the spectrum, what happens with the light is that based on what is coming off the comet, all right, the reflected sunlight will come back minus a few things, minus a few slots in that light spectrum. And what comes back is sort of a dark band. And that dark band, all right, is something called an absorption line. It's like where some of the energy of what was in the comet's halo absorbed energy. And so you just see sort of a dark vertical band in the spectrum. And the nice thing is in chemistry, those dark vertical bands are in specific places for specific elements, for specific compounds. You can't miss them. Okay.
Wow.
We know their position to the nanometer. Okay. And so they're always there. And if they're coming toward us at high speed, they're shifted a little bit toward the blue end. And if they're going away from us at high speed, they're shifted toward the red end. Okay. Yep. So that process is something we can read. We can look at the composition of comets by looking at the light coming from it. And so we do. And we can see what's going on in there. That's how we know there's nickel. That's how we know there's carbon dioxide compounds. That's how we know there's some cyanogen and carboxyl radicals. We know that there's all this stuff in there because we can see the spectrum.
Yeah, isn't that great? Well, let's see. We have a question. Did I hear there was cyanide too detected?
Yeah, cyanide is cyanogen, CN, carbon and nitrogen.
Yeah. Okay.
Yeah. And most comets have a wealth of cyanogen as well. So this one is, and as far as I could see, not particularly showing a copious amount of it, but that could be because the carbon dioxide is overwhelming it.
I see. So yeah, I have a bunch of questions as we go here, but when people are putting in questions, I'll put them up for you. Why do you think NASA hasn't decided to redirect Juno to study 3I Atlas?
Actually, that was a good suggestion Avi had. He said, why don't we have Juno just retask, because Juno is going to be deorbited in September or so, and they're just going to send it into Jupiter's atmosphere to die a fiery death because they don't want to pollute Europa or Ganymede or Callisto or one of the other moons, just in case. I mean, it's sort of like Roddenberry's prime directive from Star Trek there. Okay. Do no harm. Just, don't leave nothing but your footprints kind of a thing. Right. Well, anyway, Juno is actually somewhat remarkably well suited to looking at 3I Atlas. Now, could it show us more than the James Webb? I think so. Juno can look at the object and possibly see some structure that we couldn't see, because Juno will be much closer to it, relatively speaking. It's still going to be millions of miles away, but we're many, many millions of miles away right now. Okay, so the James Webb Space Telescope was able to show this object as sort of a blur. I think you used, I think you have those images of the James Webb view of 3I Atlas, right?
Yes, I have. I do, and
like
I just have to get to them. But I don't have the four of them. I just have the one. But I wanted to ask you. Let's talk about the Atlas telescope. And things are named like Oumuamua was named right from the observation in Hawaii, the observatory, And
Yes,
the Atlas
messenger,
was
messenger
yeah.
from the stars. Yeah.
Uh-huh. And what about the Atlas? Where is that located?
The Atlas. Let me think about that. It's the Asteroid Terrestrial Impact Last Alert System. How they do?
Oh my God! Wow, good for you
That's
to
what
pull
Atlas
that up.
stands for.
Pull
It's
that up.
it's a robotic system. Okay,
Uh-huh. Yeah.
and it's designed to look for near Earth objects that could be of danger to us. And so there's telescopes around the world that do this. I think there's a couple in Hawaii. There's one in Chile, one in South Africa, and so all part of the Atlas network. So these are all looking out in all different directions at night in order to survey the night sky and look for these dangerous objects. Now, Atlas, you know how we have our remote telescopes in the Arizona desert, right?
Mm-hmm.
Okay, I've got a wide field system, which looks at vast tracts of sky, and that's in the Sonoran Desert, west of Phoenix by about 80 miles. And then down in Benson, I have a narrow field system with a high resolution camera. Well, it's with that one, we actually took a picture of 3i Atlas. I have a photograph. Really? Yeah. It's not very remarkable because 3i Atlas is tiny. In the frame, you see a tiny dash of light, a tiny dash, because it's a time exposure. And 3i Atlas was going at the time something like 1.47 arc seconds per minute. Now, what does that mean? It means there's a very, very small amount of sky every minute. So we had to do a fairly long exposure of the night sky to catch multiple shots of it traveling through the field. And we caught a small dash of it. And it's really cool to see it. But there's our interloper right there. So we're on top of things. So, the Atlas telescopes were actually very good at looking for these small interlopers. And now Atlas is actually not that small. It could actually be anywhere from a quarter of a mile in size to a little bit larger. I mean, maybe 10 miles. So we're talking about anywhere in between. We don't know yet. And we also don't know the shape. So if you see something that looks like a long spindle, ignore it. We don't know. It's probably more like a rocky shape. Okay. More like a round object,
This is exactly what the James Webb took, right?
That is not complete with the text of him.
Yeah. No, we got this here, and there's another one. I'm not able to upload it for some reason. But here's the thing. I read something. I wanted to see. You mentioned Avi Loeb, and by the way, I tried to get him on the show, and he said, "No, I was on your show not that long ago." And I said, "No, you weren't. I sent you an email not that long ago, but you were not on the show. I was supposed to see him at some event or whatever." And anyway, long story short, he's so busy he just couldn't come on. He's been on other people's show, but not mine this time. So, right. But I wanted to read what he had to say about his latest, and he is saying now they think it might be up to 46 kilometers wide. I don't know if this is like very like in the last day or two that he came out with that. And how do you suppose they can even guess at that distance what the size of this thing is? I mean, I'm sure there's some type of science to it, but it can't have to do with the outgassing because you can't. It's not the what am I trying to think? Cornea of it or whatever it's called.
The coma.
Coma. That's
the
what
coma's out. Yeah, but the volume of debris in the coma can kind of give a hint.
Did I say cornea?
You did.
Okay.
I wasn't.
Yeah, you didn't.
I wasn't going to give you a problem.
You could have. Yeah.
No, I won't. Easy. It's okay. No. No. See, the thing is, the coma or that cloud around the nucleus of the comma. I call it a comma around the nucleus of the comet object, a cometary looking object. Its size depends on how much stuff is in the middle. So we can make a rough estimate about the size of the object based on how much outgassing there is. But this comet if it's a comet, is very different. It's outgassing a lot of stuff. It has nickel where we would expect to see more than just nickel. It has carbon dioxide where we only expect to see a small percentage of that. So it's acting differently than a normal comet would. So that's why its origin is so important. Is this what we can expect if we see more interstellar objects come from the galactic disk like this? This is coming into the plane of our solar system. That's a very, very slight chance, like 0.05% or something,
Right.
chance of that coming in at the plane of our solar system, unless
Right.
it's in the galactic disk, right? And so then it could. So anyway, if we're getting 3 interstellar objects over the last few years coming through our solar system, and there's so many stars in our neighborhood, you can imagine that interstellar objects are quite common.
It's just we're now being able to detect them a lot easier.
Yes, and the Atlas system is one that allows us to detect them a lot easier. That's correct.
Now, let me ask you something. This is a doomsday situation. Let's just say this thing was heading right at us, which, the odds would be 1 in billions, that it would happen. But let's just say an object this size, so what we think might be whatever size it is heading toward us. What would we do?
There's a couple of ways to divert an incoming object that looks like it's on a collision course. And the first thing we've noticed is that it didn't get taken off the Sentry list. The Sentry list is a list of potentially hazardous objects that could hurt the Earth. And the Sentry list, most of those objects, they come on as soon as they're found, then they go off once they figure out the orbit and realize, oh, it's not going to hit us. Okay, Apophis, for example, was thought to be a problem. It's not. They took it off the list. Okay, but let's suppose this one was going to hit us. It stayed on the Sentry list. Refinements of the orbit show it's definitely going to come in. Let's say that's true. It's not, but let's say that's true. Okay, it's going to be millions of miles away from us. It's going to be farther than the James Webb by far. So let's suppose that this object was going to hit us. There's a couple of ideas in planning by NASA to divert dangerous objects. One of them is to launch a very large nuclear weapon at the center and obliterate it. Boom! And scatter into billions of tiny little pieces. And those little pieces would hit the Earth's atmosphere. Now, the problem with that, there's always a problem with that. Okay? The problem with that is that when they struck the atmosphere, by the tens of millions, they'd heat up the atmosphere. And it could raise the temperature in our atmosphere from all these impacting meteoroids that are burning up, releasing a little heat, releasing a little more heat over and over and over, millions of times or more, could end up heating our atmosphere up to dangerous levels for life in general. Okay.
Wow.
So that's one problem. Okay. We don't want a bunch of little ones hitting us either. So the other question is, well, maybe we don't have to destroy it. Maybe we just have to nudge it.
Yeah.
And if you remember, there was this asteroid, and this asteroid that was a binary asteroid. It was Dimorphos. Okay. And they sent a ship with a kinetic impactor, a big weight basically, striking it to see if it could change the orbit of the little asteroid going around the big asteroid. And they changed it by way more than they thought they would. So it shows that a kinetic impactor, that is a impactor moving at high speed with energy of motion and mass, can possibly nudge an asteroid or a comet just enough to move it in its orbit so that it could miss us. Now, the thing is, if they do it when it's close to us, they have to nudge it a heck of a lot more than if they can do it far out in the outer solar system. Because then the smallest nudge of, say, a single 2 kilometers would make it miss the Earth by tens of thousands of miles if it was going to be a direct hit, for instance. So you want to catch it soon. So there's the nudge. Okay. Then there's the other possibility. If we had the technology, what we would do is we would actually land on the surface of this comet or asteroid and deploy rockets. And these rockets would start going and start thrusting. And over time, these little rockets will push the object further away. And so that's another way. So there's the nuclear weapon, there's the nudge, and then there's the long-term nudge using rockets on the surface. Every one of those, I would actually opt for the kinetic impactor, because that way you get an immediate result and you know it's going to work. If the rockets, there's less to fail. In other words, with the rockets, right? Rockets running on the surface, well, those could, oh no, the rocket failed, we're doomed. That kind of a thing.
Yeah, I mean, we did land on one, but I mean, that was amazing. But I mean, yeah, there's so much that can go wrong. I get exactly what you're saying.
Yeah.
Here's another question here for you. Does the mainstream astronomy still think comets are dirty snowballs? Or do they call them something else now?
Yeah, Tony, that's a good question. Here's the thing that's interesting about comets. We said dirty snowballs, and what does that mean? It means soils and dirt mixed in with ice and stuff. Comets are primarily icy, but when we talk about ice, we don't mean water ice. There's a lot of water ice, yes, but there's carbon dioxide ice. There's methane ice. There's other ices that are on a comet's surface that are bound up in soils and interstellar dust that's accumulated and mixed in with the soil and been frozen into a matrix. And as it gets near to a star, well, those outer ices begin to sublimate off, releasing the dust, which gives you that dusty coma around the front of the comet, usually around the whole comet, right? So in effect, they're still dirty snowballs with modification. Okay, there's a very elaborate chemistry that goes on inside of comets. I actually did a show, one of our SkyTour radio shows, I think, Martin, where I actually talk about the composition of comets and how that evolves over time. And so it's still the dirty snowball, but it's way more complicated these days because there's more than just snowballs there.
Well, we got a lot of questions in chat. I'm going to put them up when I can, but I just, right off the bat, I want to just say, what makes a comet or whatever this is start to move? Is it like a supernova or something what propels it initially?
That's a very good question. Let's look at our solar system first. Okay, and let me get my microphone on my face. We have our planets in a plane, okay, a circular plane, right? That's called the ecliptic, the plane of the solar system. And then beyond that, we have a region of icy bodies called the Kuiper Belt. That's Kuiper, Kuiper Belt. And beyond that, there's something called an Oort Belt, O-O-R-T, an Oort Belt, which is also a belt. But then outside all of it is a cloud, an Oort Cloud of icy bodies. And these literally go almost halfway to Alpha Centauri, maybe a little more. Okay, this cloud. So our solar system has a lot of stuff in its outer environs. And over millions of years, a star, because stars pass each other, we've gone around the galaxy 19 and a half times so far. And as we do, stars come close and we go by stars and they go by us. Well, as that happens, as a star passes near us, it'll disturb that Oort cloud and you'll see stuff move around. And then finally, on the rebound, it might start its way on the long journey into our inner solar system where it then goes around the sun and goes back out. And so a passing star can perturb or disturb the orbit of a object out in the Oort cloud like that. And thus it'll end up coming into our inner solar system. All right. Now, the other thing that can happen is there could be collisions, but those are more rare. There's actually, you could go through the Oort cloud and never see an object. Okay. You could go through the Kuiper Belt and never see another object. Okay. So those are more rare, but it's the gravitational interaction with nearby stars that actually affects them, affects those things. Now, let's go to the interstellar object. Now, that's an interesting one. Now, when I was getting my degree in astronomy, one of the theses I wrote was runaway B stars in our galaxy. Now, what does that mean? It means they're hot, young blue stars that for some reason are racing out of the galaxy at high speed. Whoa, how'd that happen? Well, what it usually means is they interacted with a cluster of stars or whatever, and as they came by the cluster of stars, they got whipped out, okay, and continued on their way out of the galaxy, okay? So that was what I studied, was these runaway stars, and found a bunch of them. Now, the question is, can this also happen to planets? Can this happen to comets and asteroids? And the answer is yes. in Orion, right? Orion the Hunter, that beautiful constellation. Well, just below the belt is a fuzzy spot. That's the Orion Nebula. That's a huge stellar nursery, a giant molecular cloud where planets are forming, stars are forming, and sometimes planets are forming without stars. And you're just getting planets forming in deep space. All right. Now, in those conditions, these planets are called rogue planets because there's no star that they're surrounding, that they're circling.
Mhm.
So the mutual gravity of nearby stars can pull them around and maybe whip them around. And next thing you know, we have this high-speed planet, moving through space. How'd that happen? It happened through mutual gravitational interaction over the last several 100 million years or a billion years or more, interacting with stuff around it. So we have the ability of these things to pick up speed based on interactions with gravity of other objects. And that's what we see here. In fact, you might ask the question, how do we know that this object is interstellar? How did we know that Oumuamua was interstellar? How do we know that Comet Borisov,
Speed, right?
Borisov, yes.
Is it the speed?
Yes. Because the speed, that cloud I talked about, a passing star that could disturb an object out in the Oort Cloud, well, that passing star out in the Oort Cloud is going to disturb the cometary body, and it'll come into our inner solar system, and it can only go so fast. It could only reach a maximum speed, and that maximum speed is way less than what we see for Oumuamua, Borisov, and of course 3I Atlas, right? So we know that by the speed, just as you said correctly, the speed is the indicator that this was definitely interstellar. I'm really fascinated by 3I Atlas because we're seeing an object that it defies all understanding of what a comet should be. Right? So
That's right.
nickel isn't there. Nickel's there, shouldn't be there in the quantity. Carbon dioxide shouldn't be there in this quantity. We're seeing some of the other stuff we expect to see in a comet. But what about this other stuff? And that has to be related to its origin story, which we're still trying to puzzle out.
Yeah. I mean, this thing, like you said, could be, we don't really know. It could be billions of years old, which is also fascinating. You said possibly even 7 billion. Did I hear you say that?
Yeah, that's correct. One of the ideas was maybe it was 7 billion years old now. You might say, well, how could they possibly know that? Well, based on how long it's been moving into our solar system and where we saw it coming from, it had to have traveled through interstellar space at a somewhat of a speed. They could calculate how fast it was moving based on what the compounds on its surface looked like. Maybe it means it was exposed to cosmic rays for longer and therefore has a different composition. I think they're going to find that the exposure to cosmic rays is primarily responsible for the composition we're seeing. That's my guess. If it doesn't turn out to be an alien ship full of hostile aliens who want to eat our brains.
I think that's what, that's always we can't even go, we can't even hide from them. So Tom King from the Phoenix Lights, one of the people that filmed the Phoenix Lights, is here in chat. And thank you all for being here. And thank you for your great questions as well. So question for Mark, does the astronomy community think Avi Loeb is a pioneer or crazy?
Well, from my perspective, go ahead. I'm sorry.
Yeah, I mean, you hear some people bashing him, but I think he's open-minded is what I think he is. My personal thoughts on that. And, I love the fact that he is looking at this with a childlike curiosity, this whole thing, including UFOs.
Yeah, a willingness to accept other possibilities. That's how I am, right? I mean, anyone listening knows me. They know that, yes, I'm a formally trained astronomer, but guess what? I'm also an open-minded one. That doesn't go well in academia. No. Okay. But it's true. I do outreach because I want people to understand the strangeness that we see out there. And so is Avi a pioneer? Absolutely. Is he crazy? No. He's brave.
Yeah.
He's actually showing a lot of courage. I've known the man, off and on for a while and for years. And
I know the first time you met was we did the show together with him. Remember?
That's correct. Yeah, that's right.
Yeah, that was
Yeah.
several years ago.
Yeah. And so he's very. I've talked to their Galileo team actually as well, because I would like to be involved and help them with a site for their Galileo stuff. And I've got 2 potential sites, maybe 3. So that might be a strong possibility. Yeah. So we have that Sonoran telescope. We have the Benson telescope. Well, if all goes well, we might also have a San Luis Valley telescope in Colorado.
Oh, nice hot spot there.
It's the darkest sky in the United States, actually, right there. I did a Skywatch out there a couple of weeks ago, and they expressed interest in this. So I have a feeling we're going to be negotiating for a possible 3rd observatory.
Awesome,
and
Mark. That's great.
Then there'll be a 4th one here in my front yard again, because the front yard here in Terryville, Connecticut, with filters, you can see some nice things in the sky. In fact, right behind me, is it there? It's over there. Yeah, there, right there. Okay, right here. Okay, there's the telescope that was in the building. It has another telescope on top of it. You can see there. So it's facing right at us right now. Okay, but that's the telescope that was in the building here. And I'm not going to put that back in the building. The front yard here is going to become a solar telescope system. And we're going to study the sun with it. And
oh, yes. I remember you talking to me a while about that. Yeah.
Yeah. So I won't get any sleep.
Yeah, that's right. Day and night. The only time you get any sleep is during, a rainy season or something.
Yeah, the monsoon season. I look forward to the monsoons.
Here's a question also, and thank you, Anonymous Rex. Thank you again, all of you people in.
Yeah, you guys are great. Thank you so much. It's really cool.
Are there near-Earth objects that act differently and end up in a gray box? Unknown.
Oh, wonderful question. As far as trying to put things in a box, I'll say this: we always try to put things in a box. Sometimes it's not appropriate. The object that couldn't be boxed was Oumuamua initially. Another object that initially couldn't be boxed but ended up being boxed was Borisov. We could put that one in a box because we figured out what it was doing. Oumuamua came and went so fast that we didn't see it till it was on its way out. And thus, and it was only brief. So we didn't get any good data on it, really, just some. And then now with 3i Atlas, this was discovered way before it reached its perihelion. It's a close approach to the sun, which is going to be in December or October. I think I got to go back and look. But the point being that this object we can study, and the more we're looking at it, the more gray it becomes. So obviously this object's in a gray box. So that was a very good question. Anon Rex.
Yeah,
it's true.
Yes, and yes, Rex has been on my show. I won't give out his because he's anonymous, as he says, but he's a great researcher and someone that I'm looking forward to talking to again. So, have we ever discovered a new metal from a comet?
No, Starzar, that we haven't seen a new metal. We've seen odd ones like just now with 3i Atlas, nickel.
Yeah.
Okay, right. But we haven't seen a new metal. The periodic table is the periodic table. That's the same everywhere in the universe, actually.
That we know of.
Well, there's no indication. You might see some isotopes that we didn't expect to see in deep space, and I'll define that in a moment. But for the most part, all the elements we see in the periodic table are all the ones that can be either naturally created or created by us in a lab in addition. So there are some that we create, and there are some that are made naturally, right? There's 118 elements in the periodic table. And yes, I can sing the whole periodic table, but I'm not going to do it.
Oh, well, I'll
Okay.
have to put you on the spot up at
I
Shag
know. Yeah.
Harbor.
Well,
Yeah.
yeah, I was saying there's hydrogen and helium, and lithium, beryllium, carbon atoms everywhere, nitrogen all through the air. Okay, never mind.
You
Oxygen,
almost
so
did
we
it.
can breathe. And
Yeah.
fluorine, for you're pretty. Okay, I can go on and on, but that was actually how I learned the periodic table, because the periodic table is a really functional, interesting table of elements, and every element that's formed in the periodic table has an origin story of its own. Okay, I'm not going to go into those, but I will say this: we can't really have more than 118 elements in the periodic table. Beyond that, they decay back to 118 or something less. And the reason for that has to do with nuclear forces. In particular, something called the strong force. The strong force is the strongest force in the universe, but it acts over a very, very tiny distance. And the strong force holds atomic nuclei together. Protons are all +1 charge, and they're all in the center of an atom, tightly packed. How can you have all these positively charged items that want to repel each other and push away from each other at high speed? How can they all be held together? They can be held together with, it's actually called a residual force, but they're held together by what's called the strong force. And it has to do with what protons themselves are made of. And I won't go into that, but the protons are held together. And when you get out to about 118 protons in the nucleus, which is like oganesson, which is the 118th element, you'd go to make, say, 119th, and they spontaneously decay back to 118 or something less. And the reason is because the strong force can no longer hold all of that size nucleus together at that size for the 118 protons. So 118 seems to be the limit. I say seems to be because who knows how that can change. Maybe there'll be something more that can make that change.
What about something that's held under pressure? Could that be like, to say, inside of say the core of a planet or something like that? Could there be elements in there that are held together because of force of compression, or am I just going way off the deep end?
No, not at all. I know where you're going with that, and you're saying, well, geez, could a massive star, for instance, be compressing something in its core? Well, that compression in a star's core is how we get fusion of different materials. The problem is, even in the biggest stars in the universe, once we make this nuclear fusion through hydrogen, through helium, carbon, nitrogen, oxygen, all the way to iron, number 26, once we get to iron, it can't fuse past iron because the amount of energy required is way more than the return you get. Like when you fuse hydrogen into helium, you get a return on your energy, which goes blasting out of the star. It's energy that comes out in addition to the energy used to fuse hydrogen into helium. But when you get to iron, you can't put in enough energy to fuse iron in such a way that you get anything back. You get way less back than that. So I think that that's part of the problem. So iron is the dead end in stars. You never get past number 26 in the periodic table. But wait, Mark, you said that there's 118 elements in the periodic table. Where do they all come from? Those come from other processes in the star. Okay, there's a slow process that actually makes elements long-term over hundreds of millions of years. That can turn carbon into nitrogen, nitrogen into oxygen, okay, and so forth and so on. And so you get some of that. You get colliding neutron stars, which make elements like gold. In fact, all the gold that we have in our Earth's crust came from colliding neutron stars at one point or another. All right, which is odd to think, which means there must have been a lot of neutron stars out there, huh? Which are the result of supernovae in many cases, if not a black hole. So yeah, I mean, the elements come from a variety of different sources and origins. However, what we see in our table is fairly well understood, and in all likelihood, with 99.999% certainty, these elements are the same no matter where you are in the universe.
Well, we've discovered about 299 metric tons of gold so far. So which is, I heard that it's like something like a couple of Olympic-sized swimming pools full. And I have conversations about this all the time. What makes something valuable? Because as an appraiser, and the rarity and all that. And there, I'm getting way off topic here, but I know that if we mined an asteroid that had, say, platinum or gold or say even diamonds, it's bound to drop the value of these things if we could actually get it to Earth and all that. But here I am, I'm digressing terribly.
No, that's a good point, because asteroid mining, I wrote a novel about asteroid mining at one point. Okay.
Oh, wow.
Yeah. And so these, the concept of mining titanium, mining gold, mining, things like silver, all right, and other precious elements is something that would be very attractive to us. But, and I covered this actually in the book, I said, hey, if we put too much of this into the market, it's going to drop the price of gold everywhere on the planet. If there's a glut, the price drops. And then people are going to buy, and then there's a conspiracy, you see, to artificially make gold go away, making the ones who bought during the glut now billionaires.
Well, there's a great Twilight Zone episode about these crooks that slept for like 100 years or something, and when they wake up, all the gold that they had stolen was worth nothing, which is pretty funny. But it really does. And also during the Civil War, right after the Civil War, Ulysses S. Grant released, I forget how much gold out into the public, and it made the economy crash. So it's all interesting. So there are some questions here, and we are going to say goodbye to everyone over at KGRA Radio here in a bit. I'd like to continue a little bit longer, if that's all right with you.
Fine.
Past the normal time here. So here's a question here. Isn't the 3I Atlas traveling through the asteroid belt?
Yeah, it's actually inside the orbit of Jupiter, which is where the asteroid belt is. So between Mars and Jupiter is the asteroid belt. So 3I Atlas is inside Jupiter's orbit. So it's actually heading toward the asteroid belt. And guess what? It may never even see an asteroid. If it had eyes, it probably could never see one. Because as much as we see pictures of the asteroid belt looking dense and got all kinds of stuff everywhere, it's not like that. It's not like Star Wars, where you had this asteroid belt full of asteroids with the Millennium Falcons diving around and getting around. That's not reality. Reality is they're so far apart, you could travel for a year out there and never see another asteroid.
Yeah. Well, it's just like if we collided with another galaxy, we may never have any collisions. The Andromeda.
There wouldn't be. Yeah.
Because it's so far apart. Everything's so far apart.
Yeah.
Isn't it all? It's just so hard to put things like that in perspective, the distances and things.
Yeah, well, Cassini was that probe that we sent to Saturn, and we sent Cassini through Saturn's rings. All right. Now, when you see Saturn in a telescope, you see these solid-looking rings. Boy, those particles must be really close together. They're not. Cassini went through there at tens of thousands of miles an hour and never hit a single particle. And they knew the statistics were on their side, that they would actually survive that. And they were. I think it did it twice.
Isn't that something?
Gluttons for punishment.
It is. The first time I looked through a telescope and saw the ring around Saturn, it just blew me away. And the moons of Jupiter. I know you see this stuff all the time, but the first time I was an adult, probably in my 40s, by the time I ever looked through a telescope to see any of that, and how exciting that is to actually see that.
It is. And one thing too, when you saw Saturn's rings, you're a lucky one, because in the future, I don't mean near future, but far future, Saturn won't have a ring anymore. There won't be many rings anymore, because Saturn's rings are falling into the planet. So Saturn's rings are a transient phenomenon that are going to disappear over time. So
wow.
I know.
Well, let's say goodbye to everyone over at KGRA. hang in there, everyone. We got this little 30-second clip. So I just want to say thank you all to everyone over at KGRA Radio.
Our
And
buddies.
next week, I will be back. I might be doing something on the DC hearings next week. And Dave Scott's slated to be on the show as well. So let me just run this. And remember to keep your eyes to the sky and hang in there, everyone else. We'll be right back. That's good enough. Don't have to run the whole 30 seconds. So, yeah, this is all exciting. And I want to get to some of the questions in the chat because there were so many of them that came in. I thought it would be kind of unfair to, not have a go at some of them too.
Sure.
But I want to, before I ask some of those questions in the chat, I want to ask you, what are some of the misconceptions and myths that you are hearing the most out there about at the Atlas?
3i Atlas, the most misconceived and misconstrued data is that it's a hostile alien ship. And it's been proven to be a hostile alien ship. Scientists say, they say, studies show. What studies where? What scientists? Who? What? And if you push for an answer, you don't get one. And that should be the first clue that it's probably not true. Everything, I did that Facebook post on 3i Atlas for a reason. And that was because I got frustrated seeing all this garbage out there, put out there just to get clicks.
Yes, there is so much in every aspect of everything. There's, there's a lot of that.
It's a It's a clickbait. It's a clickbait thing, and
it's social media. Yeah,
I couldn't handle this clickbait stuff. So anyway, the myth is yes, it's an alien spacecraft. It's coming here, and they're coming to save us from, get this, a pole shift that's going to be catastrophic on our planet.
Oh yes, of course.
There's this one guy that talks about these pole shifts. They're going to come. They're catastrophic. Does he have any idea that it's happened over 180 times already and no one noticed? Well, there's a reason for that. It's because they take thousands of years to occur. And I actually think we're in the middle of one now. The pole drifts a few miles every year, magnetic pole. And so that just indicates that the deep outer core of the Earth is going through some different gyrations, and the magnetic field is changing its orientation a little bit. And so the magnetic field moves around as well on the Earth. The Earth keeps going and keeps rotating the same way. But what happens is when people talk about pole shift, they say the Earth is gonna flip over. That's one of those major misconceptions.
Yeah,
the Earth has never flipped over.
We're going to be standing on our heads. Yeah,
Earth has never flipped over. Yeah. So with 3i Atlas, one of the other things is that it's definitely an intelligent craft going to visit Jupiter, Mars, and Venus. Well, how can you say that? And another one is, here's a photograph of 3i Atlas just released. Now that's my favorite image, just released. And it shows, no lie, the planet killer from the Doomsday Machine on Star Trek, that conical thing.
Is that the one that I put up there a little while ago, or is that something else?
That was different. But they show that conical planet killer. Remember Commodore Decker, Chris, there is no third planet. Don't you think I know that? There was, but not anymore. That was that big scene, with Commodore Chris Decker in the ship. Well, anyway, he ended up, being the star of the show as he rode a shuttle into the thing and blew up. Well, anyway, the planet killer was shown as an image of this 3i Atlas.
Yeah.
And I said, no. And I just got so frustrated. I wrote, no, nope. This is not an image of 3i Atlas. And I said, I'm going to write an article showing people what we know of 3i Atlas and what we see. The James Webb is 1 million miles out, and it's taken the best ever photo of 3I Atlas, and here it is. It's an orange blob, and the color orange is artificial coloring. So,
and why is it the speed that would make the sun have no effect on it as far as gravity?
Yeah, actually, the sun does have an effect on it. The sun is bending its path. Okay,
it is.
So when something orbits the sun, right, it goes like this, goes around, and if it's trapped, it's in an elliptical orbit. Okay, well, we're in a roughly circular orbit around the sun. Right, a circle is just a special type of ellipse where the eccentricity or the elongation is 0. And that's our circular orbit. And it's not quite circular. It's a little bit elliptical, slightly, ever so slightly. So eccentricities approaching 1 are more and more elliptical, more and more, long and narrow with these long, but they're still connected to the sun, still gravitationally bound to the sun. When the eccentricity is greater than 1, now it's unbound, and that means that the sun's gravity can't hold it because it has energy beyond what an elliptical orbiting object would have. Okay, so you can have a parabolic orbit and you can have a hyperbolic orbit. A hyperbolic orbit is one where an object comes in and it's coming in so fast that the sun has little effect other than to just bend its path a little bit and out it goes. And that's what this one's doing. And that speed is 137,000 miles an hour.
Isn't that amazing? Wow.
It is.
Yeah. So this, I do appreciate when people put questions in all caps. I think Dead End Collective here is a new person to the show. Thank you for your question here. Is it possible that this object with its straight-ish and extremely fast trajectory could be a scout from an enormous supernova out beyond Pluto, and we may expect more of these?
Well, okay. Let's take the first part of that. Let's unpack that. Is it possible this is a scout from something beyond Pluto? I can't say no, but if so, it's a pretty big scout. Okay. Right now, it's looking like an astronomical object similar to things we understand, but still different, as we mentioned throughout the show. But from an enormous supernova, no. A supernova is an exploding star, and if there was a supernova out beyond Pluto, it would wipe out life on this planet without any question. We'd see this extremely bright light, and we'd be pelted with deadly radiation from the supernova.
And that would be it. Yeah.
Yeah. So that, not that. But is it possible that its trajectory could make it like some kind of a scout? Well, I can't say no, but I would err on the side of caution and say probably not, because what we see so far indicates it's a strange type of cometary object that we haven't seen before. But I'm leaving an open mind for anything else it might be.
All right. Here's another one here from Tony. Does the electric universe theory hold any sway with you? I don't even know what that is.
Yeah, I understand. And Tony, thank you. That's a good question too. Sorry, there's a little bug flying around, so I'm swatting it all the time. Does the electric universe theory hold any sway? It doesn't. It doesn't. First of all, let me explain. Everything in the universe it deals with charge or no charge. Okay, so electrical output is very important. For instance, the sun gives off radio waves, okay? And the sun also can send off charged particles to our poles, which go swirling around the poles and sometimes blow out our electrical grids. So there is electricity in ordinary objects in the universe every day, all the time. And so we do have to be concerned about that. When we look at our Earth has these gigantic fields that are being generated. There's an electric field being generated deep inside the Earth by the molten outer core riding around the solid inner core of iron and nickel. And you got this molten core, and as it does that, this massive electrical field is made, and that electric field in return builds a magnetic sheath around our Earth, a magnetic field. All right. So the electric fields will make these magnetic fields. So that's what's going on down there. So the concept of current and electric universe is always on our mind, not to the extent where I would say that moon craters are created by electricity rather than impacts. I draw the line there big time because we've seen them. We've actually, in our SkyTour live stream, we're doing a live stream of a lunar eclipse back in January 20th of 2019. And it's on our site, on our skytourlive.org site. You go to look at, we have over 525 videos up there. One of them says meteor impact during this lunar eclipse. And during the lunar eclipse, we actually we're only one of 5 people on the planet to catch it. We caught a meteor striking the moon right at the height of the lunar eclipse.
Oh, yes. I remember that.
Remember that?
Yeah.
In the red area of the moon, the red area that was reddened by the passage into the Earth's shadow. And we saw this bright flash. And we caught a lunar impact, right? And that was an object that collided with the moon that was about 18 inches across or so. And the crater it made was somewhat larger. And it was confirmed by, there's SkyTour live stream, thank you. It was confirmed by later views of the area in question, and they saw the crater. Yeah. Yeah.
I totally remember when that happened. That was so amazing. Like, Mark's the man. Yeah. That was really great.
Yeah. We give away equipment in our streams as well, which is really nice.
All right. So I got to try to get us back. Here we are.
Yeah.
So here's that was a good question. Thank you for that. And this is an interesting one because I don't know the answer to it. How can you have carbon dioxide without H2O?
Well, pretty easily, actually, because, if you don't have a lot of water ice, you're not going to end up with H2O, but you can have carbon dioxide. Let me just give you an idea. First of all, hydrogen is the most populous element in the entire universe. It's number 1. Yay, H is number 1. Okay, the next one is helium. That's the next most populous. The second largest number of atoms in the universe are helium. The third most abundant element in the universe is oxygen. Okay, and the fourth is carbon. So it stands to reason that you'll have carbon and oxygen doing stuff together, more so than hydrogen and oxygen potentially. Now, and that's only because carbon dioxide, the carbon atom, bonds with more things than any other atom in the periodic table. All right, it has 4 slots that you can connect to a carbon atom with very, very nicely, right? And hydrogen doesn't. Okay, hydrogen has that one. And so when you look at carbon dioxide, you're going to get a lot more carbon compounds of all kinds, including that one, carbon dioxide. Okay, and carbon dioxide is very important in that regard. Now, you also get other things. You get carbon monoxide, CO, not CO2, O2, 2 oxygens with the carbon. You get carbon monoxide, mono, meaning 1, CO. And we get that as well. We get carbon-carbon, carbon bonded to another carbon atom. And we get all kinds of these compounds, and then thousands and actually hundreds of thousands of other compounds beyond that. So carbon exists in a lot of different form factors in the universe. Water is also everywhere we look. You can be sure that there's a lot of water on 3I Atlas as well. There's a lot of H2O. But we're noticing that there's a lot of CO2 in addition. So that's what's making it strange.
If it gets closer to the sun, will we most likely be seeing more outgassing of different elements?
As it gets closer to the sun, we're going to see outgassing of lots more elements, probably. If it's a comet, yes.
Yeah. Here's this person, Mendy Mendonopoulos, has really fantastic questions. Has been joining us for a number of weeks, months maybe. So what are your thoughts on Tektites and their possible origins?
Okay, well, first let's define a Tektite. A Tektite is a formerly melted blob from a meteor impact. It could be, if it struck the Earth, it could be a blob of molten Earth that fell off, and as it fell to the ground, it cooled. That's a tektite. So if we see tektites on Earth, then it's probably a piece of the meteor or a piece of the Earth itself that melted on impact and then got sprayed out from the impact site. I have some tektites over here on my shelf. And so those would be, the origin of tektites is for the body that was struck. Okay, they come from the body that was struck. And if you look at the tektites, is it possible that you got a piece of the meteor in there? Oh, yes. I have a nice meteor over there, too, that came from Argentina in a beautiful fall. It weighs 1,000 grams. It's big iron meteorite, right? But when that splashed into the ground and melted, you know that a lot of stuff flew off of it. Okay, some of that became tektites. Some of that mixed with earth debris and became tektites and fell to the ground. And some was just earth soils that were melted and cooled as they fell to the ground. If we look at Mars, we know there's tektites on Mars too. And they've identified, if I recall, Curiosity it was, they may have identified potential tektites on Mars from an impact. And that was Martian soils that were melted on impact and then flew out and cooled and then fell back, cooled to the surface.
Wow.
So, yeah, so tektites, and hopefully, Mindy, your question, I'm focusing on tektites, and maybe you didn't mean that particularly, but if you have another question, please rephrase it.
Yeah. And by the way, this really has nothing to do with anything really, but just from my world in the antique and the auction business, do you know meteorites actually sell really well at auction? They sell for a lot of money.
Are you trying to get me to give you my meteorite to sell?
That's what I'm trying to get a consignment here. Yes.
Well, I might consider it. It's 1,000 grams and it's an iron meteorite. So on the market, it's worth about $1,000.
Oh, okay. Some of them are, yeah. Well, you know that better than I do.
Iron meteorites are pretty common.
Yeah. I see. All right. So let's see how this is from Duckhead. How do we tell if something is rock or a metallic structure on an interstellar object?
That's a very good approach. We would want to differentiate, wouldn't we? And you're absolutely right. So how do we do it? Well, we would again look at the light coming from it and see if the light gives us any clues in the composition of the object. The light we're seeing coming from this object shows us nickel, carbon dioxide, some cyanogen, and a few other elements. I think carbon, etc. I think we're seeing some of that as well. But as far as metal goes, the only way we'd see the metal in the spectrum is if the metal was being melted and heated to a certain amount where it would actually spew off of the object. Then we might get a spectrum from it, and we could see that it's actually metal, right? Seeing gas, that's okay. Seeing small particles, we can do that too. We can see silicates, that are being driven off, because the silicates will also have a spectrum as they're gassing out, and their spectrum will show. But a solid metal object, we might not actually be able to tell that. It's buried inside this fuzz right now. So it's inside this coma, and whatever's in there, we can't see right now. My guess is it's a rocky core, like other comets. This comet's acting a little differently. So maybe, like I said, being formed in the galactic disk and then moving into our solar system changed how it got, how its composition was.
Now, here's another question, but I don't know if we have time to talk about this. We may bring it up later if we do at the end. But Mendy is asking if you can comment on your SRTD work on the U.S. Navy submarines. And I know that has to do with the USO, but and you've told that story at least 20 times on this show. But so we may, if we have time later, we may bring that up. But here's another question here.
Okay.
Near the last phase of star creation, silicon turns into nickel, which quickly decays into iron. Could this be the reason we are seeing such a high nickel content, but why it's covered with dry ice?
Well, okay, that's cool. Thanks, Michael. Sure. If we look at how a star when a star goes supernova, okay, the last thing that fuses in the star's core is silicon, and it makes silicon for approximately 1 day before it blows up. So any large star is, if it's making silicon, it's making it in a slow process over time, but not a lot. The supernova event, just before the supernova, there's a shell of silicon being made in around the core of the star, in the core of the star. And that is approximately 1 day long. So all the silicon we have on Earth comes from supernovae, where it was literally only happening for 1 day out of the many hundreds of millions or billion, a billion years or so of these stars' lives. And the very massive stars only live a few 100 million years at the most. So it's amazing we have silicon at all, to be honest. But is it possible that the nickel could be covered with dry ice? Yeah, it could. And the reason is because if the nickel was deposited in some way because of the galactic disk origin, then maybe it got bound up with this dry ice, CO2 ice, on the surface of this object. And so when the CO2 was liberated, so too were the nickel particles that were there as well. And we could be looking at, as I said, a very strange composition from a very strange origin story for this object. So I'm pretty good. Can you put his comment up again so I can make sure I didn't miss anything?
Yeah.
Okay. It's quickly thinking. Yeah. Could this be the reason we're seeing a high nickel content? Maybe. I don't know for sure, because we don't really understand yet where this nickel content actually is coming from. So it's just speculation. But the thing is, the nickel content is something that we're seeing, and it's something that we don't know how to explain at this point. I can't say where it came from, but I will say that seeing it without a lot of iron content is kind of odd. And so I have to just say that much of it. I don't know anything beyond that.
All right, another one here is from Tom King. We can't tell the size of a UFO video because it's just one angle. He's talking about triangulation. So how do we know the size of 3I Atlas from just one angle?
Oh.
I mean, well, let's just ask the question. How do we know the size of this thing at all?
Okay, that's very good. Very good. All right, first of all, it's moving through the sky. And as it's moving through the sky, all right, we can calculate its distance based on its parallax as it's moving. And that kind of gives us an idea of where it's going. It's kind of a rough idea. And based on the amount of distance it has, we can figure out that, hey, this is how fast it's going. And so its speed is going to relate to its size in the following way. As we get an idea of how far away it is, all right, and we look at the coma, that area around the core, everything has an uncertainty factor associated with it with 3I Atlas. Everything. We don't know a definitive size, all right, but we can estimate it based on what we see with comets. When we see them that far out, when we see the size of the coma, we know that the nucleus is probably a certain size to give off that much stuff. All right, so there's that. So it's really a lot of guesswork based on seeing previous comets that just come in. And we're trying to put this thing in the same box as a comet. And I have a feeling we're going to be in for some surprises, because I don't think this thing is the same type of thing as a regular comet that we're used to seeing.
Now, here's a question. I think you may have addressed this. This is from Starzar. How do we measure the age of comets? Didn't you say it's because of where it might have come from?
Yeah, I mean, that's one way. For instance, if something comes in from the outer Oort Cloud, okay, around our solar system, we know that formed about 4.6 billion years ago, right? So we know the age of the comet is it's going to be perhaps thereabouts 4.6 billion years. But if it's coming from outside our solar system, it makes what's that? Oh,
I don't mean to distract you. I just thought that was funny. I'll put it up after.
okay.
Yeah.
Yeah, put up that previous question, please, or that previous comment.
All right. I have to find. Oh, how do we measure the age of comets?
Oh, yeah. Sorry. And yeah, so the age of the comets, as I said, if it's coming from interstellar, it means it's come from a long way off. And based on its speed, we can figure where was we reverse engineer. How far did it come from? Where did it come from? And we may not be able to know exactly where it came from. But we know, based on a couple of things, we know based on the chemical composition on the surface, how long it may have been exposed to cosmic rays. Okay, for instance, on the moon, we can tell the age of lunar soils based on how much cosmic ray damage or how much cosmic ray composition change has occurred in the soil. All right, so younger lavas are going to be lighter and older lavas are going to be darker. Okay, well, same thing with comets. Comets are generally very, very dark, almost black, right? And that's the core. That's because they've been exposed to radiation for many billions of years. So when we see it from out of the solar system like this, we know it's more than 4.6 billion years old. It's literally much more than that. So the estimate of 7 billion years was just an estimate, and it was based on perhaps the compositional changes at the surface of the comet that we're seeing. And maybe, and this is kind of new science. We haven't seen this before.
Right.
So everybody's scrambling to try and come up with ideas, you know?
Yeah. It's exciting. It really is.
It is.
Oh, this is just a comment. I think it's pretty funny. Tom King says that you're here, or he's watching you on the computer, and you're also on the TV in his living room. His wife is watching a show on UFOs. So I think that's pretty funny.
I'm everywhere, Tom.
You're everywhere. Yeah. Can't get rid of him.
You can't get rid of me, much as you try. You try shouting him out. You try scrubbing him out. And still he keeps showing up.
Let's see. I'm not sure about this question here. What if they're not here to save us, but to warn us? Warn us from...
Well, okay. I mean, that makes an assumption that they're here and that 3i Atlas is them. There's been no indication of that yet. Although I will say that the trajectory coming through our solar system is a curious one, going by Jupiter, Mars, and then Venus. That's kind of cool. But if it was an advanced civilization, they would have seen the little pale blue dot that we are and known that the oxygen in our atmosphere indicated there's probably life here. So why wouldn't they steer it toward the Earth too and have it zip by the Earth as well? I don't know. Maybe they're doing a Juno. Maybe they're doing a Juno thing. They're gonna, they'd rather not affect anything near the Earth, and in case it goes off course, they don't want it to hit the Earth. So they're going by Mars and then by Venus, and from that distance, they look at Earth and make some judgments. Just like rather than let Juno just continue to orbit Jupiter, they're going to send it into the Jupiter atmosphere and burn up.
Well, what if the thing just puts on the brakes right beside us? You never know.
I would actually be very impressed. That'd be tough.
Gene Sticko, who was visiting us yesterday, but also was on the show last week. Okay. What are the odds? And we'll give him a break for not putting the question in cap here. So what are the odds? It's just something unique that hasn't been observed before by science.
Oh, the odds are all 100% already. We have not observed a cometary object that has a CO2 emission like it has, or nickel. So your question is very pertinent. It's 100% at this point.
Right.
Yeah,
thank you.
It's an oddball.
It looks like Michael has some great questions. Michael Nelson, you're new to the chat. I believe so. I'm not aware of you being in here before, but thank you for your good questions tonight, Michael. So nickel from exploding star fusion and CO2 from freezing cold pressures seem contradictory because one requires extreme heat and the other extreme cold. How can both exist together?
The answer is because they happen at vastly different times. Okay, the nickel was forged in the heart of a star, absolutely, and it was at huge temperatures. Okay, millions, hundreds of millions of degrees Celsius. Okay, but that nickel was also floating around in the universe, and as it does so, it's going to cool down, and you're going to have all these nickel atoms. You're going to have nickel isotopes flying around, and then you're going to have an object that has some gravity of its own and maybe attracted nickel to its surface. And then that object may have had an abundance of carbon dioxide, carbon, cyanogen, carbon monoxide, and other carbon-based molecules on its surface. And thus, the nickel could end up combined with that material because it didn't happen at the same time. It happened at different times. And this is what's really important about this object. It shows that it's gone through some type of evolution. And I think that that's something that you'll see come out soon, actually, with this thing. So they can exist together because they happened at vastly different times. The nickel was made, and then the object was made, and the objects came together over time at some distant location outside our solar system.
Mark, what do you say? I think we've had some really good questions tonight.
I'm very impressed with these folks here. These guys are something else.
Yeah.
You know?
Here's another one here from Starzar. Do you think that the U.S. Space Force has taken an interest in I-3 Atlas?
3i Atlas. Well, yes.
3i Atlas. Yeah.
No, he wrote it that way. It's okay. Well, they better because the Space Force also has to deal in part with that Sentry list. And so they better be watching this object very carefully so that it can be taken off the Sentry list. And as I said, the Sentry list is that list of objects that could potentially pose a threat to us or a collision. And in this particular case, this object is far less of a threat at this point because the calculated path and this hyperbolic trajectory take it far millions of miles away from the Earth. Right? Yeah, so we're not going to have to worry about that. But I think that the people that manage the Sentry list and Space Force, they're probably all going to be looking at this object very carefully. Space Force primarily deals with satellite environment and the health of the satellite environment. Okay, and that's
as far
good.
As we know.
Yeah, of course, as far as we know. That Martin. Yeah, that's true.
All right, here's another great question from Michael. How can you account for the extreme luminosity from the object that started when it was so far away from the sun?
Well, the object itself, excuse me, the object itself is outgassing a lot of material that's reflecting a lot of the sun's light to us. So that accounts for how bright it looks so far away. But you got to keep in mind that the object, and this is why we don't know how big it is, okay? Because, is it that giant coma that we're seeing? Because in a star, the larger the diameter of the star, okay, the higher its luminosity, right? So the larger the coma, the higher the luminosity or brightness, obviously, intrinsic brightness of the object. And that's kind of what we're seeing here. So in this case, I have a feeling that the object itself is got a large coma of material around it. We call it a coma, yeah. And it's just like a fuzz. Now, the interior part might be this big. It might be a little tiny rock in there, okay, maybe. But you got this giant coma, which can be millions of miles in size, surrounding it. And when the thing...
Corona, yeah.
The coma. Yeah.
I'm sorry, I'm just teasing. Yeah.
The corona, yes, the corona.
Yeah.
Yes.
So this is another interesting question. In this case, would the age rule out a spacecraft?
Well, Wyatt, think of it this way. First of all, let me answer that. No, not necessarily. So would the age of this thing rule out a spacecraft? No, because I believe that there could have been a race of intelligence that started billions of years before us. Maybe. I don't see why not. Okay. Just because we started 4.6 billion years ago doesn't mean you couldn't have a race of creatures begin, 10 billion years ago, you know. I don't see that as a problem. And we don't have any civilizations we found yet to actually see that or show that for sure, definitively. But it's interesting, when we look at this, because this object is moving into our inner solar system, and it's going to pass millions of miles from Earth, yes. But the point is, how in the world did this object actually form in the first place? That's one of the things that we don't really know. We don't know where it formed. We have an idea. Okay, everything's an idea with 3I Atlas. Everything is an idea. Okay.
Yeah.
So
with everything all the time. Yes.
Yeah, we don't have a definitive answer for Atlas right now. Once it gets closer, we might.
I think I asked you this question earlier, but maybe not. How is it outgassing towards the sun?
Yeah, that's a good question. We don't know. The only theory I can think of is that there's so much of this carbon dioxide bound up on the surface with nickel atoms and so forth that when the sun hits it, it's the carbon dioxide is forming jets that is causing this material to shoot off, just like we see on many comets. Churyumov-Gerasimenko from the Rosetta mission, I have photographs of the jets blowing off material off the comet's surface. It looked like a strange peanut. Okay, and so if it's shooting these jets off, it'll shoot them in any direction. And if it's a large enough body with a large enough amount of material on its surface, it might shoot this material forward in its path. So maybe that's what we're looking at. So hard to say. I don't think it's an illusion effect where the stuff is actually trailing behind it, but because it's curving, it looks like it's in front of it. Okay, if this is the object moving here and it's traveling this way and trailing and going like this and trailing stuff behind it like this, okay, you might think this is in front of it when in fact it's actually behind it, curving behind it. I mean, it could be an illusion, but I don't think so. I think they may have figured that out already.
And let's see, is it expected to exit and never return? I mean, this could take a billion years to return again, right? I mean, you never.
It's expected to exit and never return.
Never ever return. Okay.
Yeah, it's on a hyperbolic trajectory, which means that it's got way more energy than it needs to get out of the sun's gravity well as it passes. It's going to put on quite a show. I think it's going to be quite a show.
And what do we say? October 29th is when it's going to be the closest.
Yeah, the only trouble is it's going to end up being in the glare of the sun, so we're not going to be able to see it for a while.
Yeah, it's doing it on purpose.
Yeah.
Another question here by Tim: what happened to all the independent helioscopes around the planet?
I don't know that anything happened to. You talking about telescopes?
I don't even know what a helioscope is.
I mean, it's a sun-looking telescope. I mean,
okay.
Yeah, and so
maybe you'll have the last one, Mark. Yeah.
Well,
Well, we'll have to ask Tim what he meant by that. But here's another one from Gene Sticko. Any insight or opinions on Dr. Virilio's transients and uncorrelated targets?
Yeah. One of our viewers, Isabella Melamed in Bulgaria, she's an astronomer without the degree. Okay. She studied Villaros. I know Beatrice. I've talked to her, but she studied Beatrice's frames, and then she looked at the whole frame and found that there are 1,300 transients throughout the entire frame, and it had to do, as Isabella suggested, it may have had to do in part with the emulsion of the film that these were taken with. Now, I used 103 AO film, and I know there are artifacts with 103 AO film when I was doing my work in the observatories back when I got my degree. And this was done well before that. So it's possible that these are artifacts in part created by the film. So every dot is not a star. So if you take a picture and then take another picture and it's gone, you'll say, oh, it's gone. How could the star disappear in just 50 minutes if it was never there in the first place?
Well, I thought they had looked into that. Now, I've been in touch with Beatrice. She's been on before, and I'm trying to get her back on, but
Yeah.
to talk about this. But I thought she was careful to look into that, so that wasn't part of the problem. It wasn't an artifact. But anyway, more will come out as that.
Yeah. I mean, the only problem, Martin, is that she looked at a small square of the frame, okay, and counted those transients, the stars that seem to disappear, etc. Right? But there's a big frame associated with that she didn't look at. It's a whole frame, and she looked at a small piece of it. All right, a small, several arc minute by several arc minute size. I forget the exact size, but there's a massive frame from that survey, and they're all throughout that. So, are they really transients, or could they be something else? And Isabella argued that maybe there's something else. And she's not trying to say Beatrice didn't know what she's doing. Of course not. She's just pointing out the possibility that maybe we have to consider that some of these are transients. And it's really hard to tell what a transient is versus, an actual star sometimes, because they can look identical, especially with film. There are ways to study the emulsion directly. Isabella didn't have access to the actual negatives to study. That would have been good because it could have been emulsion. It could have been related to the photographic substrate it was put on later, to show the image. So there's a lot going on here that I thought her work was great and groundbreaking. Beatrice anyway. I liked what she did, but I wanted to see whether she had addressed the artifacts in the entire frame, and I've never seen her address the artifacts in the entire frame. Because
when she comes on again, I'll try to remember to ask her that particular question. So I'm going to ask 3 more questions, and then we'll wrap up the show. I'll come through. Here's another one from Michael Nelson. Does any of the dust and particles that are sublimating from the coma of the 3I Atlas have any chance of drifting into Earth's orbit, since they probably have some momentum?
And that's let's unpack that. Whenever we see a meteor shower, it's the result of us passing into a comet tail from a previous passage of a comet. Okay, Comet Swift, Halley's Comet, other comets. We drift into their tail stream, the dust tail, and the meteors are from that. Their Earth's gravity pulls them in, and we get these meteors. It's really nice. But that's where meteors come from, meteor showers. Well, in the same way, the comet that should actually provide us with some kind of a meteor shower has to pass close enough to us. And this one is not going to pass close enough to us so we can actually get an orbital display of meteors from it. It's going to be too far away from the perspective of its entry and exit in our solar system. We're not going to pass through its tail. So we won't see anything from this comet.
I think I've heard you talk about silicone-based life forms. How is it possible?
Silicone or silicon?
Yeah. Oh, yeah. Sorry. Yeah. What I have heard you talk about that before, and
I have. Yeah, I have. You're right. And let's talk about the periodic table again, because here's how that works. Right, in the periodic table, and without going into a history lesson of the periodic table, let's just talk about the elements as listed. Okay, let's go to carbon, number 6. Okay, directly below carbon is silicon. Okay, now the columns are set up in this table such that the next atom down is most like the one above it in characteristics and capabilities. So This is why people say, what about silicon-based life? They don't say, what about magnesium-based life? Or what about, phosphorus-based life or something like that? And the reason is because it's not in the column. The column is the most similar atom, okay, kind of a thing. So after carbon, the only possible one that could possibly support life below that is silicon. All right. And they get increasingly less populous in the universe as you drop down. But if you look at carbon, it has 4 spots for things to bond to it. Okay, those are called valence electrons. Don't worry about that. But when you talk about all the many millions of compounds you can make from carbon, the thing about carbon is, and it's called the granddaddy of all elements for a reason, is that you can make and break bonds with carbon so much easier than any other element in the periodic table. And it makes bonds and breaks bonds so much easier. Everyone watching right now is making and breaking thousands upon thousands upon thousands of carbon bonds in their bodies as they watch me say this sentence. Okay.
I knew I was tired for some reason.
You got it. And in fact, it does relate to how much energy you have. In fact, energy is required to do all that work. So the body, you need more sugar. But the bottom line, okay, is that when we watch carbon do its job, we might think, hey, what about silicon? That's just below it, and that's most like carbon. So maybe there's silicon-based life. Valid assumption, valid. I mean, Star Trek did it with the Horta, no kill eye. Remember the Horta was a silicon-based creature? Well, Star Trek kind of portrayed a possibility of a silicon-based creature. But the problem with silicon extends to beyond whether it can actually harbor life forms and harbor the changes required to make life viable. It comes down to the fact that silicon is tenacious, and when it bonds with things, it tends to make a crystal. All right. And when it makes a crystal, it typically takes a lot of energy to break that crystal apart. So, example, one of the silicon compounds that we're also familiar with is sand. Silicon dioxide.
Yep.
Silicon dioxide. Yeah. So silicon with 2 oxygen atoms attached to it, right? So that means that, if it was like carbon, then you could put sand in water and maybe separate them apart, and you can't. It's too resilient. Maybe you can, melt them. Yes, you can at high temperatures, right? It takes a very, very high temperature to melt sand. And when it does melt sand, it gets a big flash of brightness and then it's gone. Those are the atoms being separated because their binding energies are so high for silicon and 2 oxygen atoms. That said, when you actually look at silicon as a potential life, habitability element, as something that might be useful for life, you need a lot of energy to break a silicon bond. So when a grain of sand, silicon dioxide, enters your Earth's atmosphere 90 miles over your head, you see a bright flash. We call it a meteor. Okay. Well, that's the size of a grain of sand.
Right.
90 miles away. You can see a grain of sand 90 miles away as long as it's on fire.
42,000 miles an hour or whatever it is, right? When it hits
yeah. So it burns up, and that's the kind of energy that you need to separate those atoms from each other. And that means that silicon is not very useful for life's processes because the energy required to break the bonds is way too high. And we don't see that in a biological carbon-based creature.
Well, you've mentioned Star Trek several times tonight, so we can't leave without you doing James Kirk.
I don't believe for 1 minute, Scott, back me up here. Silicon bonds to oxygen and makes sand. Well, that's it, right? I mean,
that's it.
That's it.
Thanks for doing that. I put you right on the spot. But yeah, Mark, thanks so much. It's been a real pleasure. And you're the best. I mean, here I contacted you a few hours ago and you said, sure, I love it. So I
Well,
like your spirit and I like your brain too. You have a lot of great information.
brain power.
That's right.
Well, hey, the
Yeah.
truth is, you got a great audience, Martin, and unfortunately, Katie couldn't make it. Love Katie to death. You know, the
Yeah.
great good friend. Sorry she couldn't make it.
Yeah.
And to basically be part of her company is a good thing. So, and in your company too, you're a good guy.
All right, man. All right, we'll see you up in Shag Harbor.
I'll be
in
there.
Just a few weeks coming
Yes.
up. Show up.
Yeah, that's
All
right.
right.
I'll be there. Mm-hmm.
All right, so SkyTour, everyone, check that out over at telescope giveaway. Woo!
Oh yeah, we give away telescopes and binoculars. Yeah,
And it's skytourlive.com or .org. What is it?
both. It's a
Oh.
it's a 501c3 nonprofit,
Yeah.
and our whole point is to bring astronomy to the masses, and we don't charge them for anything. And
Yeah.
we do. They can support us if they want. We have a Patreon and all that. But the bottom line is that we give away equipment. We give away the pictures we take too. So
Excellent.
when you see a picture you like, it's like, wow, that's such a beautiful picture. Guess what? It'll be yours 30 seconds after we save it. And you can just
Beautiful.
go up and grab it. Oh, yeah, it's a lot of cool fun.
Yeah. Yeah. Excellent. Thank you, Mark. And I'll talk to you soon.
Thanks,
All
guys.
right.
See you later.
All right. Good night. All right, everyone. So don't forget next week, Tuesday, I'll probably be talking. I might have two shows on Tuesday talking about the hearing, which I'm not going to be. It's going to be the first. I'm not going to make it to it. It's the first one I'll miss out of the. This will be the third one that is open to the public, and not going to make that one this time. But anyway, I'm going to try to cover it. I'll try to get some help there to get some information about what is going on and all that. It's possible Tyler Roberts and I might do something together on that. We met for the second or third time, I think it was, this weekend at Exeter, and he was interested in doing something. Not sure if that's going to happen. So Dave Scott next week on Tuesday, and Charles Lear on Thursday of next week. Thanks so much, everyone. Remember to keep your eyes to the sky.